In this tutorial, I just want to go over how to write a chemical equation when you're given the different components of that equation. Once we get into Unit 2, then we'll actually begin trying to figure out, if you're given, a couple of reactants, how do you figure out what products you're going to form? That'll come a little bit later on, especially since on the AP exam, that's a major focus. So I just want to be able to go over that with you and then try to, iron out all the problems and whatever, together and not have to do it, virtually as we are now. So, again, I just want to go over how to do a basic chemical equation, when you're given the words, and then also how to go about balancing a chemical equation once you have that equation set up. So in this first example, here we have phosphorus reacts with oxygen gas and it yields diphosphorus pentoxide. Now there are a couple of things that you need to pay attention to. First of all, when you have an element within your description, in this case phosphorus and oxygen gas, you need to make sure that you know which ones are diatomic atoms or actually diatomic molecules, because those will occur in twos, not just one. And also you need to make sure of, if you're given a chemical name, you need to check to see what type of name you've been given, whether it's ionic or covalent, because you will deal with things a little bit differently depending on what type you have. So let's take this one first. Probably the first suggestion I would make is to write out a skeletal equation using the description that you've been given. So in this case you have phosphorus and it's reacting with oxygen, meaning plus, and it's oxygen gas. And that yields diphosphorus pentoxide. So let's just take this in steps. So you have phosphorus. Is phosphorus one of those diatomic molecules? No, it can just be represented by a P. So that's phosphorus. Plus oxygen gas. Was oxygen gas one of those diatomic molecules? Yes. So that means you'd have to have O2. It wouldn't just be O, because oxygen doesn't appear in nature as just one element. It's always in a molecule. So then you have yields diphosphorus pentoxide. Well, now you have a chemical name. You need to figure out if this chemical name is an ionic compound or a covalent compound. In this case, because of the fact that you have prefixes, it means it's a covalent compound. So all you simply have to do is phosphorus is P, you have two of them because it's di, oxide is just oxygen, so, and you have pentoxide, so that's 5. So that's how you go about doing that. Now as far as balancing this, first thing that I strongly recommend is that you go back and make sure that this is correct, that the word equation is correct, because if it's not, when you're trying to balance the equations, it's probably going to be impossible to be able to balance it because of the fact that you don't have the correct formulas. So in this case, you have a P and the O on one side and a P and the O on the other side. What I recommend is that you just go back and forth, looking at the same element on both sides until you actually get it to balance out. So let's say in this case we look at the oxygens. On the left side you have 2 oxygens, on the right side you have 5. Common multiple between the two of them would be 10. So in this case you could have 5, and in this case you'd have 2. And that would balance out the oxygen there, which is 10, and the oxygen there, which is 10. Now though, your phosphorus aren't balanced out. And if you look, you have 4 phosphorus on the right side, so that means you'd have to put a 4 there to make it 4 phosphorus on the other side. So a lot of it is just trial and error. You're going back and forth. There are some tips that I can show you, once we get into the ionic compounds, to make it a little bit easier, but for the most part, like I said, it's trial and error. Just remember that when you have coefficients, those do multiply through to each of the subscripts, and that you can't change the formula of the substance itself. So you couldn't go and change the 2 in P2O5 to something else, or the 5 in that to something else. The formula itself you need to keep, so it has to stay P2O5. But you can change the coefficient in front. And that's the only thing that you can change. Alright, so in this next example, let's do the same thing. Go through and do out the skeletal equation first. And this is a step that you can skip once you become comfortable with this. I'm just going through it just to show you each of the steps and try to make it a little bit easier. So you have, if you read through, you have hydrogen gas. So there's hydrogen. That's coming together or reacting with oxygen. And that would be oxygen gas. Because it says it's oxygen in the air, and that's going to yield water. So here's your skeletal equation. Now we need to go through and do out the chemical equation, or the symbols with it. So hydrogen gas, is it one of those diatomic molecules? Hydrogen gas is, so it would be H2. Oxygen gas, is another one of those diatomic molecules, so it would be O2. And then water is just regular H2O as you know it. Now to balance this out, if you look at the hydrogens, both hydrogens right now are balanced. They both have 2. So let's move on to the oxygens. In this case, you have 2 oxygens. Over here, you only have 1. So you'd have to put a 2 in front. Again, you cannot change the oxygen at all. You can't change the subscript. You need to keep the formula together as H2O. So that's why we put a coefficient in front. This changes the hydrogens now, though. You now have 4, so that means you'd have to put a 2 here to balance that out. So the overall balance equation for this would be 2H2 plus O2 yields 2H2O. This last example has a little bit more meat to it. It's going to be a little bit more difficult to do. If you read through and you notice, you have calcium phosphate, you have copper 2 chloride, you have copper 2 phosphate, and then you have calcium chloride. Every one of those is a chemical name. They aren't elements and they aren't diatomic molecules, so you do have to go through and figure out what type of compound they are. Calcium is a metal, copper is a metal, so that means every single one of these is an ionic compound. So you have to figure out the formula, with the ionic rules. So for example, you have calcium phosphate. If we go back and do like we did before, calcium is just regular Ca. It's in the second group, so it has a positive 2. Phosphate is one of those polyatomic ions that you need to memorize, which is PO4 negative 3, plus copper 2 chloride, which copper 2, and I actually put that the wrong way, where copper 2 is just regular Cu. Because of the fact that it has a Roman numeral, that means it has a plus 2 charge. And then chloride is just regular chlorine, which is Cl. It's in group 17, which means it gains 1 electron, so it's a negative 1. That takes care of the first half. This forms copper 2 phosphate. So again, copper 2 is just Cu plus 2, phosphate PO4 minus 3, plus calcium chloride, so calcium Ca plus 2, chloride, which is Cl minus 1. Now the thing is, you can't leave them with charges. You do have to make sure that you go through and get rid of those charges and have them just as subscripts. So you do have to go through and do your crisscross rule for each one, which I'm running out of room right now. But you have just like that. And if you were to write this out, you have Ca over here, so it would end up being Ca3, PO4, 2, like that. Then you'd have, which I gotta erase some of this. Then you'd have the Cu, which would be 1 coming down, Cl, which is 2, like that. Then you'd have the copper 2 phosphate, which would be Cu3, PO4, 2, like that, and then you'd have Ca2Cl, which would end up being CaCl2. Now this looks like it's going to be extremely hard to balance out, but in reality it's already balanced. Actually, no, it's not. I lied. It's almost balanced. So if you look at this a little further, you have Ca over here, which you have 3 of them. Ca over here, which is only 1, so you put a 3. If you look at the Cus, you have 1 Cu on the left, 3 Cus on the right, so you'd have to put a 3 there. That changes the chlorines to 6, but you also have the chlorines at 6 there. So the Cas are balanced, the Cus are balanced. Now if you look at the PO4, which is one of the tips I wanted to show you, PO4 is in parentheses on both sides, so keep it in parentheses on both sides, meaning just look at the subscript that's outside of it to see whether or not it's balanced. So in this case you have PO4 2, meaning you have 2 PO4s. If you go over here, you notice you also have 2 PO4s. So that means those are balanced out, so your equation itself is all balanced out. You know, so it takes a while to get used to balancing, but again, I think this is a topic that you've already gone through, you know, with honors chemistry. You know, if you need any more practice with it, you know, just let me know and I can give you more than just the problems that I have for you to submit for a grade, and I can help you out a little bit more as well.